Okay, welcome back. In this video, we're going to go over the basics of Coulomb's law, which is a law that describes the attractive forces or repulsive forces between two charged particles. For the sake of this lesson, we're only going to focus on the attractive forces between two oppositely charged particles, and that is the case of something like a proton and an electron. Okay? Recall that opposite charges attract each other, and according to Coulomb's law, if the distance or radius is very small between those two oppositely charged particles, they will experience the greatest force of attraction. Okay? This is because they want to be close to each other, because they're attracted. On the opposite end, however, if the distance or radius between two oppositely charged particles is large, then they will experience the smallest force of attraction. And this is because they can't attract when they're far apart. And this will really come into play when we're looking at how easy it is to gain or lose an electron. The basic rule of thumb of Coulomb's law is, for attractive forces, Coulomb's law says that a short radius or small radius equals large attraction. Okay. So just to review the basics of Coulomb's law again, small distance between two oppositely charged particles means they have a very high force of attraction because they want to be close to each other, and they are close to each other. However, when the radius or the distance between them is large, then that attractive force is very, very small because they cannot attract each other at great distances. Let's see what this looks like when we're looking at how atoms hold on to their electrons in the different energy levels. Okay, I have a simple atom right here, and in the center in red is the nucleus. And remember, the nucleus of an atom has a positive charge. The nucleus of an atom has a positive charge, and the electron has a negative charge. This means that overall, the electrons experience an attractive force from the nucleus, and that's what keeps electrons in the atom. It's the attractive force by Coulomb's law between the positive nucleus and the negative electrons. However, each one of these electrons, and I've color-coded them different here, gray, blue, and green, will experience a different attractive force based on their distance from the nucleus. For the gray electron, it is closest to the nucleus, so the radius between the positive and negative charge is small. This means that the gray electron experiences the greatest attraction. Okay? And because it experiences the greatest attraction, it is held tightest by the nucleus. Okay? You're going to have a very hard time getting this core electron out of here because it is so close to the nucleus and experiences such a high attraction. For the green electron, which is the furthest away, because that distance between the nucleus and the electron is so far, this will experience the lowest attraction. And because the force between them the attractive force between them is so low, this one is held the loosest. Okay. These outer electrons, these valence electrons, are very easily removed because they're so far from the nucleus. And then the middle electron, the blue one, is kind of just in the center. It experiences a medium attractive force. But because it's a core electron, it's still very hard to get out of there. Okay. Alright, ladies and gents, so that is the basics of Coulomb's law. The equation from Coulomb's law is not one you will have to use in order to solve mathematical problems. You just need to be able to explain the concepts of it, which is what we discussed in this video here. In the next two examples, you'll go over how to identify core electrons and valence electrons, and then determine which ones are more tightly bound and which ones are more loosely bound.